For years, Elon Musk and Tesla have had big ambitions to electrify the world and break the planet's addiction to fossil fuels. In order to do that, Tesla has started with electric vehicles to go after internal combustion engines, one of the primary consumers of oil products in the world. Each electric vehicle, of course, is powered by electrons stored in massive batteries, which are currently on the order of $10,000 to produce for a car the size of the Tesla Model 3, for example. Tesla has built a Gigafactory in Nevada with the help of Panasonic, capable of producing over 30 gigawatt hours of energy for usage in electric vehicles and also in home or commercial battery storage solutions. This has helped bring Tesla to a production level of 400,000 vehicles per year, mainly Model 3s, and this has made Tesla the largest producer and consumer of batteries in the world. However, even with new Gigafactories being built in China and in Berlin, they are still nowhere close to producing enough batteries that could possibly power enough vehicles to even make a dent in a market whose size is 100 million internal combustion engine cars per year. When Tesla first unveiled the Gigafactory, Elon Musk stated that they only needed 100 Gigafactories to transition the world to being electric. Of course, this may have included other companies' Gigafactories, but even at Tesla's current rate of putting up about one new Gigafactory every year or two, even if that rate were to speed up, it would still take decades for Tesla to achieve its goals. That's why Tesla needs to stop putting up Gigafactories and start building Terafactories. Let's have a closer look at what this means. But first guys, if you're enjoying this video, please hit the thumbs up button to help support us, and be sure to subscribe by hitting the bell button to be notified of our upcoming Tesla content. On Tesla's most recent earnings call, Tesla CFO Zachary Kirkhorn said that Tesla's Gigafactories were in fact getting larger, and then Elon Musk chimed in to say that they may even be called Terafactories soon. Have a listen.
I'll also add that our Gigas have gotten bigger.
Yes.
And
arguably could start being called Tera.
Yes, with multiple products as well. And so, the absolute number of Gigafactories we may ultimately build might be less, but each one is larger. And that's under a belief that it's just significant efficiencies by having as much as possible and similar product lines under the same roof, and as much vertical integration as possible all in one facility.
Now first off, Gigafactories have become more streamlined over time since Tesla's first attempt in the United States. For one thing, in the US, Tesla has the Gigafactory in Nevada, whereas the assembly plant is in Fremont, California, making them far apart and less efficient. Going forward, Tesla will have battery production and assembly at the same site, as we're seeing with Giga Shanghai and the upcoming Giga Berlin. Now you would expect that by being more streamlined, more densely packed, and more efficient, Tesla could save a lot of space and make the Gigafactories a lot smaller. However, the factories are actually getting even larger, as we heard from Zach Kirkhorn on the conference call. Also, the footprint of Tesla's first Nevada Gigafactory is 15 million square feet, whereas the newest Giga Berlin will have a footprint of 30 million square feet. That's double the footprint, albeit including assembly as well. But it hints at the fact that Tesla is planning for something much larger than its original factory design. Could Tesla eventually build a Terafactory, a single manufacturing site capable of producing 1 terawatt hour of energy or more in the form of batteries? And does Tesla even need such a large factory? Would they have enough demand to satisfy the output of this plant, or would it be overkill? So let's look at Tesla's first assumption that they need 100 Gigafactories. They initially thought that a single Gigafactory would be capable of producing 1 million cars per year. So far, it hasn't ramped to that level, yet we're seeing the limits of Tesla's US factories being reached. While Tesla sold 367,000 vehicles in 2019, the current Giga Nevada plus Fremont factories combined seem to be nearing a capacity of 500,000 vehicles per year. Therefore, to satisfy world demand of about 100 million vehicles, not taking into consideration ride-sharing, robotaxis, or other automakers, or anything of the sort, but the world would actually need approximately 200 Gigafactories at the current rate of production, assuming no efficiencies are gained with each new design. That's a lot of Gigafactories. Even 100 would be extremely difficult to manage and would require multiple companies, so 10, 20, 30 factories for a single company simply adds more complexity. Elon Musk has said multiple times before that Tesla is striving to put a Gigafactory on at least every continent for local production. And you can see here Antarctica gets one too. So why not strive to put fewer factories, but each one capable of satisfying a larger geographic area thanks to increased production capabilities? Well, the name Gigafactory comes from the fact that the factory is capable of producing total yearly energy output at the gigawatt hour level. The current capacity of battery production lines at the Nevada Gigafactory is about 34 gigawatt hours. A Terafactory would therefore only need to be about 30 times this in order to hit 1 terawatt hour. Even though giga means billion and tera is trillion, they don't actually need 1,000 times more batteries, just 30 times more since they're already at 34 gigawatt hours. So at 30 times the current 500,000 vehicle capacity that they have, that's about 15 million cars per year. And these are cars such as the Model 3 and the Model Y. So now it seems like that would be overkill since we have companies such as Volkswagen and Toyota tied for around first place that only produce 10 million cars per year. So 15 million seems like we're really pushing it in terms of how many cars a single company can produce and from one Terafactory nonetheless. Well, actually, we're missing a couple things. As I said before, a capacity of 1 terawatt hour would allow Tesla to produce 15 million Model 3s or Model Ys. These vehicles use about 75 kilowatt hours per vehicle in terms of battery size. But at the same time, while these cars are extremely popular, I'm not sure that they'll have enough demand for 15 million of them per year. Thankfully, Tesla has a few other uses for batteries as well. The first is that batteries can be used simply as batteries for utilities and other commercial uses. Tesla's energy division has been held back due to a shortage of battery production at their facilities. Currently, Giga Nevada already produces on the order of 2 gigawatt hours per year, which we sort of put aside when doing our previous calculations. Tesla could ramp up battery deployments without limits, with the Terafactory of course, in a market that Elon Musk believes can actually be larger than vehicles. Furthermore, batteries are used in combination with solar panels to store the energy from the sun for later use. In its latest quarterly release, Tesla stated that 40% of solar deployments also opted in for a Tesla Powerwall. Given that solar is such a small portion of the business, as it expands, it will boost home battery demand. So what else does Tesla need batteries for? About a year ago, Elon Musk said that Tesla would be trying to increase the number of projects that the company can bring up at the same time. The first was Model 3 in the US, which was a single project. Then Model 3 in China, Model Y in the US were both brought up at the same time. A future phase could be to bring up 3 projects at once in the United States: the Roadster, the Semi, and the Cybertruck. Tesla has had to continuously push back these projects, and the main reason is due to lack of batteries. The Tesla Roadster, while it's an expensive, high-end, low-volume vehicle, still packs a 200 kilowatt-hour battery, almost triple the size of a Model 3. The Tesla Cybertruck, on the other hand, will be a higher volume than people think. Tesla reportedly has over 600,000 pre-orders for this vehicle, which outpaces the Model 3 pre-order count when it was first announced. The number one competitor, Ford, sold 900,000 light trucks in the United States alone in 2019, so the Cybertruck does have a very large market to go after. Additionally, about 80% of the Cybertruck pre-orders were for the dual and triple motor versions, the tri-motor having 500 miles of range. That's going to need more kilowatt hours than a Model 3 for sure. Third, there's the Tesla Semi, which has been delayed to 2021 due to the global health crisis, but mainly again, Tesla doesn't have enough batteries to produce this thing at scale. The Semi will have a 300-mile and 500-mile version, and could have a total weight plus load of 80,000 pounds. So in order to achieve this range, you guessed it, it's going to need a lot of batteries, probably a lot more than even a Cybertruck. Some people are saying maybe 500 to 1,000 kilowatt hours of batteries on board. Also, semi-trucks are some of the biggest polluter vehicles on the road, given that they're driving long distances and use a ton of fuel to carry such weight. Tesla's mission is to replace the world truck fleet as fast as possible. Therefore, instead of producing 15 million Model 3s and Model Ys, which didn't sound too realistic, producing just a couple million semis, pickups, and roadsters combined would use an equivalent number of batteries. Actually, if the Tesla Semi uses a megawatt-hour battery, then a Terafactory would only allow Tesla to produce 1 million semis per year and nothing else. So Tesla may in fact need more Terafactories. And we haven't even begun looking at new products that Tesla hasn't even announced yet. Finally, if Tesla somehow has too much battery capacity still, which seems unlikely given what we just discussed, but Tesla could supply other industry manufacturers with battery packs. To be fair, this would be a little strange since Tesla currently has partnerships with Panasonic, Cattle, and LG Chem to supply Tesla with batteries. So if Tesla eventually produces its own batteries that are more efficient, the first logical step would be cutting out the middlemen to save money before supplying the rest of the industry. Okay, so we've seen that having a Terafactory would be pretty useful for Tesla, but how can they achieve this going from 34 gigawatt hours to a terawatt? Well, the first thing is that you can't assume that Tesla can simply build a building, call it a Terafactory, and suddenly have the capacity that it needs. It's clearly a complex process with manufacturing equipment that's required as well as materials for batteries. Elon Musk has hinted in the past that Tesla may even get into the mining business to help with supply. But here are some of the other ways that Tesla could go from Gigafactory to Terafactory. Denser batteries. A large contributor in increasing the output of a factory is the battery density. Tesla has some extremely exciting announcements for the Battery Day, likely to happen in May. There have also been many calculations done on the internet for the Tesla Semi's range using battery technology from a few years ago, saying that having a truck with that kind of range is impossible. However, a denser battery would solve many range and weight issues. Also, if a Tesla factory simply outputted more energy-dense batteries, the factory size wouldn't change, but Tesla would be a lot closer to a terawatt hour. Number 2, remove steps in the production process. Tesla acquired 2 battery companies, Maxwell and Highbar. These guys are experts at making battery equipment, and Maxwell has a method of making dry electro batteries, which removes steps from the production process and hence could speed it up along with some other benefits. Number 3, increase the rate of production. Tesla's first try was the Nevada Gigafactory, where they had to continuously find efficiencies in the battery production lines in order to get closer to their installed capacity. For example, even with 34 gigawatt hours installed, Tesla was only achieving 23 gigawatt hours for quite some time before they worked hard to improve this. With all of the new learnings that they have and the ability to produce a new factory from scratch, the battery production lines could get a significant improvement in speed. Number 4, increase factory size. Finally, the actual size of the factory could be increased to add more production lines and multiply the number of batteries being outputted compared to their first Gigafactory. So to summarize, with a clean slate, over time Tesla could boost efficiencies in multiple areas to drastically increase the number of watt hours that a new factory could produce. In about a month or so, Tesla is preparing to announce its second Gigafactory in the United States, likely on the eastern side of the country, and there's rumors from Elon that it could be in Texas, which would make it close to SpaceX. But with streamlined factory design, after all this would be Tesla's 5th factory, and next generation battery technology that Tesla will likely announce at Battery Day, how close do you think this new factory will be to becoming a Terafactory? Let us know in the comments what you think. Alright guys, thank you so much for watching. I hope you enjoyed this video. Please hit the bell button to subscribe and be notified of upcoming Tesla videos. Don't forget to smash the like button to help support this video. And you can also check us out on Patreon at patreon.com/themarketisopen if you wanted to give us more support. Thanks again.